Welcome to the Unit 7 conic section over circles. Let's get started. Now on your notes there's an area for definitions. First is that a circle is a set of all points equidistant from a given point called the center. So you've got a circle, and that just means that you have a center and that all these points are the same distance away from the center. And then your radius is a line segment whose endpoints are the center and a point on the circle. So one of the endpoints is the center, the other one is a point on the circle. And of course your radius can be here, it could be anywhere, just as long as the endpoints are the center and a point on the circle. Now the standard form of the equation of a circle is going to be x minus h squared plus y minus k squared equals r squared, where your center is your hk and your radius is just r. And remember here that when you're looking at an equation like this, you're going to change the sign of your h and your k. When we were working with the parabola, we only changed one, but with the circle, you're going to change both signs. Okay, so some things to think about. An axis of symmetry. When you had a parabola, when we've been working with the parabola, your axis of symmetry cut right through the vertex, right through the middle of your parabola. Cut it into two equal halves. A circle, an axis of symmetry with a circle, is still going to cut that circle into two equal halves, but now it's going to go through the center. So an axis of symmetry with a circle must pass through the center. And then how many lines of symmetry are there? As long as it goes through the center, and that didn't go through the center, you've got infinitely many lines of symmetry. So the parabola only had one, your circle is going to have many. Alright, so on the examples, we've got x minus 3 squared plus y plus 5 squared equals 16. So the center is my h and k. Remember, this was an h, this was a k. And we just changed the signs. So our center is 3, negative 5. And our radius, remember on our equation, this was r squared. So our radius is the square root of that number there, which is 4. So on the next example, our h and k, there's nothing there, so that's 0, 0. Our center is at the origin, and our radius is 6. So the next example, they give you the center and the radius now, and they want you to put it into an equation in this form. So our center is hk, and then this is our radius. So we have x plus 2 squared plus y minus 5 squared equals 9. So this was our h, negative 2, we changed the sign. Our k was negative 5, we changed it to positive. And then the square root of this number is 3, our radius. Alright, and now on this example, they give you a circle, and they want you to find the center from your picture, and the radius, domain and range, and then write an equation. So you can count that your center should be 3, negative 5. And your radius, remember radius is just from the center to the circle, so you could draw your radius anywhere and count how long it is. So 1, 2, 3, 4, 5. So this is 5 units long. So our radius is 5. Now with a center and a radius, now we know our equation, just like we did in that other example. X minus 3 squared plus y plus 5 squared equals 25. Now the domain and range of a circle, we've done these before, and domain is just your x values from left to right, and what helps sometimes is to draw lines on how wide your circle is. So then when you're going along your x-axis, you can see where the x values start on that circle. So in this case it would be -2, and this is 8. And your graph is easier to read than this one. So the circle, the domain is from -2 to +8. We have brackets because they touch those points. And then the range is red. They're the y values from bottom to top, and so it's red from the bottom to the top. And again, I'm just using a different color to show the height of my circle. And I'm just going to read this from bottom to top. So if I'm going from on the y-axis, this is -10, and again, this is easier to read on your graph, -10 to 0. So that's my range. And the next question they ask you is y equals x a line of symmetry? Well, you could draw the line y equals x. Oh, actually, I'm sorry, yours says y equals x minus 8. So is y equals x minus 8 a line of symmetry? And that's where you need to draw that line on your graph. So you start at -8. So it should be right here. And you move with your slope, which is 1. So we're going to move up 1 over 1, up 1 over 1, up 1 over 1. And you should see once you've drawn all your points and connected them, that it does cut right through the center of that circle, which means it is an axis of symmetry. So is y equals x minus 8 a line of symmetry? Yes. All right, so now we want to look at what happens when our equation's not in standard form, and it looks like this. Well, we can put it in standard form with 3 steps. Your first step is to move your c to the other side, and your c is just a number that's by itself. So we're adding 16 to both sides to move it. So that's our first step. The next thing you want to do is group your x's and y's together. So in this case, they're kind of already grouped together, but you group them together in parentheses. So my x squared, there's nothing else that's an x, plus, and I've got a y squared and a minus 6y. And then I'd move my 16 over here. So first we moved our c over, then we grouped our x's and our y's in parentheses together. And then the last step is to complete the square, which we've done before. We did it last semester when we were doing quadratics. And what we have to do with that is add a little space. And so the x squared, we don't complete the square because it's by itself. So we're just going to kind of hang out there. But the y squared, now we add a little space or a box. And what we put here, and this is what you'll have to remember, is b divided by 2 squared. And that goes right in there. So here's my b, -6, divided by 2 is -3, squared is +9. Now what you have to remember is whatever you put in that box, you've got to add to the other side, because we have to keep our equations equal. So now we've made this a perfect square trinomial. We've added this to the other side. So our x squared is still kind of here. And then this, since we made it that perfect square, it becomes y minus 3 squared equals, and this is 25. So now we have it in that form that we just learned, where our center is going to be 0, 3, and our radius is 5. Okay, so let's try this example together. Remember, first we want to move our c to the other side, if we have one, and we do. It's 50. We move it over here, it becomes -50. Now I'm going to group my x's and my y's together. So I've got an x squared and a 14x, so they're going to go together in parentheses. And then my y's, y squared plus 6y, and that equals -50 over there. Now we want to complete the square, so I'm going to leave a little box. In this case, I've got to complete the square of both, so I'll leave a box on both for both equations. And then my b divided by 2 is 7, squared is 49. And remember, you've got to do the same to the other side. And then here My b is 6, divided by 2 is 3, squared is 9. And then I've got to add that to that side also. Now all I have to do is write my perfect squares. So this becomes x plus 7 squared plus y plus 3 squared. And over here, this adds up to 8. And so now I have my equation in standard form like we learned. My center is -7, -3, and my radius is the square root of 8. Now see if you can try the next example on your own, and on the next slide I'll put the answer to see if you got it right. So this is what you should have gotten for example B. X minus 9 squared plus y minus 9 squared equals 109, which would make your center 9, and your radius the square root of 109. That's it for now. Thanks for watching and see you soon.